Hi everyone, this is surds now, so we're going to try and be quite quick because there's a big section to go through. Um, right, so simple surd problems and examples. Same as before with our support. How do we get this going? So we're trying to simplify this as a single thing for the question one, a single kind of equals where everything's all together, everything's been mixed together. So I want to simplify probably in the form ax to the n plus bx to the m, if that's the requirement. Let's go. X cubed divided by x to the minus 2. Well, let's just remember that a to the x divided by a to the y is the same as x to the minus y. So if you've got the same number with a different power, if you divide those powers, the powers subtract. So using that logic, this is x to the 3, there's my a to the power of x, minus, and now I've got my y minus 2. So this is x to the 3 plus 2, so this is x to the 5. Done. And you could look at it another way, that's x cubed over 1 over x squared, isn't it? That's what minus 2 means, so x to the power of 2, so 1 over it. So as soon as you see a minus, you're saying 1 over that thing. So 1 over that thing to the power, okay? So as you know with fractions, that flips up. So that's x cubed over 1 times x squared over 1, which gives us our x to the 5, alright? So probably best to stick with our rule of a to the x divided by a to the y here. Okay, so let me just write that out again. A to the x divided by a to the y is a to the x take y. Okay, cool. So number 2, D. This is the same as, look, when you've got our rule a to the x to the power of y, this is the same as a to the x times y. So that being said, we've got x to the power of 2 raised to the power of 3 over 2. So I'm saying if you've got a power and then raised to another power, the powers times each other. So this is x squared times 3 over 2, which gives you x cubed, because the 2 cancels. 2 times 3 over 2 goes. Okay, next. 9x to the 2 over 3 divided by 3x to the 1 over 6. So 9x 2 over 3 divided by 3x 1 over 6. Best way here, again I'm going horizontally but I really shouldn't. Best thing to do in my opinion is to split this up. So numbers next to each other and all x's stuff next to each other. So that way they're comparable. So 9 over 3 is 3. And now we're back to our a to the x divided by a to the y situation, aren't we? Okay. So this is going to be x to the 2 by 3 minus 1 over 6. I need the denominators to be the same. 2 over 3, if we times top and bottom by 2, that's 4 by 6 minus 1 over 6. So that's 3x to the 3 by 6, which is half. So 3x to the half. Okay? Let's go again. But this time we're going for the evaluation of numbers. So 25 to the half. A half, square root, means to the power of a half. Cube root means to the power of 1 over 3, right? So this is square root of 25, which is 5, obviously. 4 to the minus 2, as we know, a minus means 1 over. So this is the same as 1 over 4 squared, which is 1 over 16. 3 over 4 to the power of 0. Anything to the power of 0 is 1. Anything. A million to the power of 0 is 1. Okay? That's because most things are, when you say 100 to the power of 2, let's say, that's the same as 1 times 100 times 100, yeah? So if you say 100 to the power of 1, that's the same as 1 times 100. So if we say 100 to the power of 0, that's just 1. Do you see? That's how the logic works there. Okay, finally 27, 27 over 8 to the power of 2 over 3. So this is the same as, remember, everything in here is being raised to that power. So that's 27 to the 2 over 3 divided by 8 to the 2 over 3. You see, it times is everything, or it raises everything to the power. 27, first off, we'll deal with that over 3. So remember what that over 3 means? It means cube root. So the cube root of 27 is 3. So we're still left with 3 squared. The cube root of 8 is 2. So we're still left with 2 squared. So this is 9 over 4. And we're done. Okay? You guys are now required to do this one. So this is for you. Okay? So stop the tape. Do your packs in here. Okay? Just be careful with this. I hate mixed numbers. So no mixed numbers. Alright? Just write that as that's 7 over 5, isn't it? Okay? So that's 5x to the power of 7 over 5. No mixed numbers. Alright, so you guys do that. That's in your pack. I'll have a look at that. And now we're on to more examples. This is a situation when we've got x to a power equals 16. And we're trying to get x by itself. So find x. So my recommendation to you is not to start moving everything and writing fifth roots and all that kind of stuff. Let's just use the indice rules that we know. If I'm trying to get x by itself, first off I need to get rid of that minus. So if I raise everything to the power of minus 1, that gives me x to the 2 by 5, because remember a to the x y is the same as a to the x times y. So minus 1 times minus 2 over 5 is 2 over 5 equals minus, that's 16 to the 1, isn't it? So 16 to the 1 times minus 1 is 16 to the minus 1, which is 1 over 16. And again, I need to get x by itself. So first off, I need to get rid of this 2. So if I raise everything to the power of a half, okay, then I get x to the 2 over 5 times a half, which is a fifth, equals 1 over 16. So square root of 16, square root of 16 is 4. So this is 1 over 4. But remember, this is plus or minus 1 over 4 because I'm square rooting an x value. I'm square rooting both sides. X could be either one of those values to make this work. Finally, I need to get rid of the fifth. So again, if I raise everything to the power of 5 on the left, I need to raise everything to the power of 5 on the right. So this would be x, because the fifth times the fifth, 5 is gone, plus or minus stays, and 1 over 4 to the power of 5. So 4 to the power of 3 is 64. 4 to the power of 4 is 64. 256, and then times that by another 4. 256 times 4, so that's 1024. Okay. Oh, blimey. That calculator, that was a bit nasty. Okay. Second example. Let's do that again. So this time we've got 3x to the minus 3 by 4 equals 81. I'm trying to get x by itself, so naturally I've got to get rid of that 3. So I'm going to divide both sides by 3, 27. Again, I've got a minus there, so I'm going to put both to the minus 1. So that leaves me with x 3 by 4 is 1 over 27. I've got a cubed here, so I need to get rid of that. So I'll raise everything to the third. So that gives me x to the quarter equals 1 over 27 cube rooted is 1 over 3. And then finally, we are back to raising everything to the power of 4. So there's 4. So that now gives me my x. 3 to the power of 4 is 81. So we get 1 over 81. And we're done. Let's continue. So that's that one. Now we got this one. X to the 3 by 2. So x 3 by 2 is 64. Raise everything squared. Ooh, do not want to do 64 squared. That'd be horrible. Do you see? It doesn't matter what order you do it in. Just make it the easiest one. So I'll cube root everything first. So I get x to the half equals 4. And now I can square everything and I get x equals 16. There you go, done. So let's put a line down there. And then next one, 2x to the minus a half, so 2x to the minus a half equals 16. Again, need x by itself, so let's divide by 2 first. Minus there, so minus there. So x to the half equals an eighth. And now x then must equals plus or minus. Oh, sorry, that's x to the half still, isn't it? So I need to now square everything. So x equals 1 over 64. Done. Cool. And then the last one is this one. I'll rub out this first one now. Okay, cool. So, rubbing out the first one, 3 over x to the minus a third equals 2. How are we going to deal with that? Well, remember our power stuff. 3 by itself is the same as x to the 0. So you could look at that as a to the x over a to the y again, right? Remember, x to the 0 is 1. So that is 3x to the 0 minus a third equals 2. So therefore that's 3x to the third equals 2. And now we can go for it, can't we? Because if we divide by 3, we get 2/3. And now we sort our powers out again, just like before. Cube everything, so that's 8 over 27. And it's done. You see that little trick there? You could do that, or you could look at it like 3 over 1 over x to the third equals 2. Again, the fraction comes up, and you'll get the same result, okay? So, your turn again. Stop the tape, do these ones, make sure you can do it. Last set. So, harder indice problems, sorting out all of our indices. Okay, so I want to write this in the form ax to the n plus bx to the m, okay? So first one, that's obviously half the square root, so that's half, isn't it? So that's 2x to the half. This one, we need to expand out our brackets, right? So a third x cubed times x minus 2 over 3 x cubed. Remember, a to the x times a to the y is a to the x plus y, so the powers add together. So a third x cubed times x to the 1 is x to the 4 minus 2 by 3 x cubed. Done. Second, this one here. You got a fraction here, and you got one thing plus another. So remember, everything on the top is being divided by x. So it doesn't matter if we write it split up. So 2x over x plus 3 over x is exactly the same as the whole thing being divided by x. So again, the x's cancel, so that's 2 plus 3. 1 over x is the same as x to the minus 1, isn't it? Because remember, the minus means 1 over whatever that thing is. So that's done. Next one, expanding out brackets again. So this is x cubed minus x squared plus 2x. Yeah, done. Okay, this one, 3 over x squared. Well, that's the same as 3x to the minus 2, isn't it? Because the minus again means 1 over. This stuff, I would never, ever write square root signs. I would put them in indice form straight away. So we know x cubed on the bottom is the same as having to a power of a negative 3 plus, and then our root is x to the half. Next, let's split this up again. So we've got a splitter just like before. 3 can stay where it is. Okay, you could write that as 3 over 1 if you like. And then you could, so all your numbers are together and all your x's are together. And remember that's 6x to the minus 1. So that's 3x squared minus 1 in the power. Just leaves you with x to the 1. And there's your answer. Cool. That's that one done. And then finally, we've got this one. So this will be timesing out. The 3 stays, x to the 4. And now we've got 3 lots of x squared times 2x. So that's plus 6x cubed. And we are done. Okay. And it's your turn. So now you do these. Okay. Next video.